In this video, I introduce one more concept in sequences, that is limit superior and limit inferior. Limit superior and limit inferior of a sequence. Say in these sequences, I have defined limit of a sequence first. What is limit of a sequence? And when we say that sequence converges, if a sequence xn converges to L, then L is called limit of a sequence. When do you say that xn converges to L? If for epsilon greater than 0, there exists m belongs to n, that is a positive integer or a natural number, so that mod xn minus xm is less than epsilon for all n greater than or equal to m. Then we say that xn minus L is less than epsilon for all n greater than or equal to m. We say that sequence converges to L and L is called limit of the sequence, and we have developed this convergence of the sequence in this manner. But sometimes what happens, limit superior and limit inferior are defined first, and limit of the sequence is defined in terms of limit superior and limit inferior. Say I have defined limit of a sequence like this. When do you say that sequence xn converges? If for epsilon greater than 0, we can find out a positive integer n, however large it is. For all n greater than or equal to m, mod xn minus L is less than epsilon. Then we write L is limit of the sequence. Limit of the sequence. Then limit of the sequence, limit point. I defined limit point also. When do you say that sequence, when do you say that L is limit point of a sequence? Limit point of a sequence if this neighborhood of L, a small neighborhood of L, contains infinite number of terms of the sequence xn. Small neighborhood of this L contains infinite number of terms of the sequence xn. Then we say that L is limit point of a sequence. This limit, the meaning of this is also a small neighborhood of L contains infinitely many points of the sequence xn. Then L is called limit of the sequence. Here also limit point is slightly different, because if there is a unique limit point for a sequence, then this is called limit of a sequence. A given sequence has many number of limit points, because there exist many real numbers whose neighborhood contains infinitely many terms of the sequence. But if this limit points, these limit points, that is unique, if the sequence has a unique limit point, then it is called limit of the sequence. So this is, I think, clear. What is limit of a sequence and what is limit point of a sequence is clear. Limit point means if the neighborhood of L contains infinite number of terms of the sequence, then it is called limit point. And if a sequence has unique limit point, then it is called limit of a sequence. Now I introduce one more concept here: limit superior, limit inferior. Sometimes what happens, the subject first limit inferior, limit point is defined, then limit inferior and limit superior are defined. Then limit of a sequence will be defined in terms of this limit superior and limit inferior. That is one more approach to study the sequences. But I have defined limit of a sequence first, and convergence of the sequence, then algebra of limits, then Cauchy's theorem on limits, then monotonic sequences, subsequences, then what is Cauchy sequence, general principle of convergence, that is Cauchy's criteria. Now in this definition I give what is limit superior and limit inferior, and one or two important results here. One important theorem I explain. Say we are restricted to the syllabus given to us here. Limit superior, limit inferior. I introduce what is the definition. Then one or two important results on this. That is about the sequence, about your syllabus. That completes your syllabus. That is, sequences will be completed. Now some results on limit point. Results on limit point first. Limit point of a sequence. I repeatedly tell you, don't confuse with the limit point of a sequence and limit of a sequence. Limit point means a sequence may has many limit points, but if the sequence has only unique limit point, then it is called limit of a sequence. Now this limit superior, limit inferior are defined in terms of limit point of a sequence. Therefore some results on this limit point I revise. First one, every bounded sequence has a limit point. Every bounded sequence has a limit point. First result, limit point. Second one, the set of all limit points. Set of all limit points of a bounded sequence is bounded. Limit points means there may be more number of limit points. We consider all the set of that limit points. If the sequence is bounded, then the set of all limit points is also bounded. And third one, every bounded sequence has a greatest limit point and least limit point. Every bounded sequence has greatest limit point and least limit point. These are some results on limit points. First one, bounded sequence has at least one limit point. The sequence of all limit points of a bounded sequence is bounded. Third one, every bounded sequence has greatest limit point, least limit point. These three things are important. Now see the definition of limit superior and limit inferior. Definition: limit superior. So the definition is like this: limit superior, or it is sometimes called upper limit. Definition: let Xn be a bounded sequence. You know the definition of bounded sequence. When you say that Xn is bounded, Xn is less than or equal to k, or mod Xn is less than or equal to k, then we say that Xn is bounded. For all n, mod Xn is less than or equal to k. Suppose Xn be a bounded sequence. The greatest limit point of the sequence is called the limit superior. Greatest limit point, limit superior of the sequence, and it is denoted by limit superior Xn, or n tends to infinity, it is limit superior Xn, n tends to infinity. So greatest of all the limit points, the greatest limit point of the sequence is called limit superior, and it is denoted by limit superior, this notation, or limit superior Xn. Similarly, we define limit inferior. So limit superior is nothing but it is greatest limit point, and limit inferior is similarly defined. What is that? Xn be a bounded sequence, the least of the smallest limit point of a bounded sequence is called the limit inferior of xn, and it is denoted by this. It is denoted by limit inferior xn, or n tends to infinity here, limit inferior xn n tends to infinity. I think definition you followed. What is limit superior? Greatest limit point of the sequence, and smallest limit point of the sequence is called limit inferior. Now, smallest limit point of the sequence, that is inferior of the limit inferior of xn is less than or equal to limit superior of xn. This is evident by the definition, because what is limit superior? Limit superior means it is greatest of the limit points, and limit inferior is smallest of the limit points. Therefore, limit inferior is less than or equal to limit superior. And also the, what is that? 1 minute. Yes, limit, suppose xn is not bounded above, then limit superior of xn we write infinity. Suppose xn is not bounded above, limit superior of xn is infinity. Similarly, sequence xn is not bounded below, we write limit inferior of xn is minus infinity. Now, one or two important results here. Only I give the statement here. First result is a number L is the limit superior of xn, sequence xn, if and only the following conditions are satisfied. L is called limit superior of xn if the following conditions are satisfied. What are that condition? First condition, for each epsilon greater than 0, xn is greater than L minus epsilon for infinitely many values of n. Say, suppose xn is limit superior, then for each epsilon greater, xn is greater than L minus epsilon for infinitely many values of n, and at the same time xn is less than L plus epsilon for finitely many values of n. That is, we prove this, but we in your syllabus, that is this theorem is not there. But we use the statement of this theorem. So I give the statement only. Understand what is this? L is limit superior of the sequence if these two properties are satisfied. What is that? xn greater than L minus epsilon for infinitely many values of n. Many values of n. And xn is less than L plus epsilon for only finitely many values of n. Because L is greatest limit point here. Limit superior means greatest limit point. So these two conditions are satisfied. Similarly, number L is limit inferior of xn if the following conditions are satisfied. What is that? Each epsilon greater than 0, xn is less than L plus epsilon for infinitely many values of n. So it is, what is this? Limit inferior. What do you mean by limit inferior? The smallest limit point. L is smallest limit point. Therefore, xn is less than L plus epsilon for infinitely many values of n. It is the smallest limit point, L. So, the terms of the sequence are like this: xn less than L plus epsilon for infinitely many values of n. But xn is greater than L minus epsilon for finitely many values of n. Finitely many values of n. These are the properties of limit inferior and limit superior. Now we come to the important theorem which gives somewhat relation between limit superior, limit inferior and limit of a sequence. This theorem, now I state in through this theorem. For that, of course, we have to use these two previous results. I skip the proof of that two results theorem. Interested students, you can refer any text here. Real analysis by Shanti Narayan. You can refer real analysis by Shanti Narayan. Proof for these two. Now theorem is like this. This gives the relation between limit of a sequence and limit inferior, limit superior. What does theorem states? A bounded sequence xn converges to L if and only limit superior of xn is equal to limit inferior of xn. A bounded sequence xn converges if limit superior xn is limit inferior xn. What is limit superior? Greatest limit point. Limit inferior, smallest limit point. Greatest limit point, smallest limit points are equal means once again we come to that one. What is that? Limit point is unique. Therefore, that becomes limit of the sequence. Now, this gives the relation between limit point of a sequence, limit inferior, limit superior, and the limit of a sequence. There are two parts here. If and only if. Suppose condition is necessary. That means if a part here. If a part condition is necessary. What is that? Let the bounded sequence xn converges to L. Then we have to prove that limit superior is equal to limit inferior. Suppose first part or if part it is, or we say that it is condition necessary. Suppose xn converges to L. Then L is the only limit point. Only limit point of the sequence. Limit point of xn. Because if there is a unique limit point, then it is called limit of the sequence, and we say that sequence converges to L. L is the only limit point of xn. Hence, L is the greatest limit point as well as the smallest limit point. Smallest limit point. This implies greatest limit point means limit superior. Limit superior xn is limit inferior xn. This is condition necessary. Now condition sufficient. Condition sufficient. What do you mean by this? Suppose limit superior is equal to limit inferior. Let limit superior xn is equal to limit inferior xn. Suppose it is each is L. What do you prove? L is the limit of the sequence. For that we use previous theorem. Now L is the limit superior xn implies, but see the previous theorem, xn less than L plus epsilon, xn less than L plus epsilon for all n, for all except finitely many values of n. Finitely many values of n. This is property of limit superior. It is L is limit superior implies xn is less than L plus epsilon for finitely except finitely many values of n. This implies there exists m1 belongs to n such that xn is less than L plus epsilon for all n greater than or equal to m1. Take this as 1. Xn is less than L plus epsilon for all n greater than or equal to mn. Similarly, L is the limit inferior of xn implies xn is greater than L minus epsilon for all n or for all except finitely many values of n. Finitely many values of n. Many values of n. Again, this implies there exists m2 belongs to n such that xn is greater than L minus epsilon for all n greater than or equal to m2. Take this as 2. This as 2. Now, suppose xn is greater than L is the limit superior, then what happens? Xn is greater than L minus epsilon for all except finitely many values of n. This implies m2 belongs to n such that xn is greater than L minus epsilon. Now m is maximum of m1 and m2. This implies here xn is greater than L minus epsilon, less than L plus epsilon. This implies L is the limit of xn. Limit of xn. Or limit xn is L. Now this completes the limit superior and inferior. Only definition is there, and this theorem at the most may be asked. And go through the video. If you have any difficulties, you can ask at any time. Thank you.